Nearly 4,000 species of snakes slither across our world today. From lush jungles to sun-scorched deserts, they thrive on every continent except Antarctica. Some are dazzlingly colorful, others masters of camouflage. Some glide silently through trees while others burrow beneath sand. A few carry venoms capable of ending life in minutes, while others kill by the crushing force of their coils. They are both feared and revered predators wrapped in mystery. Yet snakes as we know them, sophisticated, elegant, and deadly, are the result of a story that stretches back more than 100 million years. To uncover their origins, we must journey to the late Jurassic and early Cretaceous periods between 160 and 100 million years ago. This was still the age of dinosaurs. Towering sauropods, grazed horned ceratopsians began to rise, and predators like Allosaurus stalked the land. But hidden beneath the canopy of primeval forests, another story unfolded in the shadows. Small, unremarkable lizards scuttled through roots and leaf litter. From these modest creatures, something extraordinary would emerge: the very first snakes. Life in dense forests was unforgiving. To survive, lizards squeezed into tight tunnels, twisted among roots, and chased after insects, worms, and other small prey. The narrowness of these habitats demanded change. Over millions of years, some lizards began evolving longer, sleeker bodies. Their limbs, once tools of agility, gradually shrank. Evolution, driven by natural selection, favored forms that could glide like shadows through soil and underbrush. Contrary to the common belief that snakes lost their legs from disuse, their transformation was far more complex, a slow sculpting over endless generations. The fossil record preserves this transition with uncanny clarity. One of the most fascinating finds is Najash rionegrina, discovered in the windswept badlands of Patagonia. This creature, living nearly 95 million years ago, was unlike any modern snake. Its body was long and flexible, its jaws hinged to open wide, allowing it to swallow prey larger than typical lizards could handle. Yet unlike modern serpents, Najash retained a sacrum pelvic girdle and even two small hind legs. These limbs were not large enough for walking, but they were not useless. Scientists believe they may have aided in gripping during mating or even assisted in burrowing. Najash was a transitional being, a living sketch in the blueprint of snake evolution. Picture Najash not as a sleek predator gliding silently, but as a strange hybrid, a creature that undulated its body across desert sands, while tiny legs trailed awkwardly behind. In that awkwardness lies a profound beauty, the fossilized moment when lizard was becoming snake. For millions of years, this form endured, bridging two worlds. But Najash was not alone in its experimentation. Another ancient transitional form, Pachyrachus, emerged around 98 million years ago. Its fossils were found preserved in marine limestone near what is today Israel, hinting that some early snakes explored the seas. Like Najash, Pachyrachus carried hind limbs, but they were even less functional. The ocean, with its open expanses and fluid resistance, favored serpentine motion. Limbs once useful for gripping land became hindrances here. Slowly they diminished, fading into vestigial remnants. And here lies an echo that reaches us today. Modern boas and pythons still carry internal traces of those ancient bones, pelvic spurs, small hooks near their tails that serve no role in walking, but whisper of a bygone era. They are ghosts of legs, long vanished fossils, written into living bodies. Cultures throughout history have woven myths about serpents, perhaps because their form carries both familiarity and strangeness. A creature with no legs yet moving faster than many with four. A predator that strikes without warning, swallowing prey whole. To ancient eyes, snakes blurred the boundary between what was natural and what was otherworldly. Some traditions saw them as divine tricksters, others as symbols of rebirth and immortality. In the serpent's shifting, limbless body, people perhaps sensed echoes of its evolutionary story, a creature that had once walked, but chose instead a more secretive path. By the end of the Cretaceous, snakes were already diverse, lurking in deserts, forests, and shallow seas. They were no longer merely lizards without legs. They were becoming predators designed for stealth and power. Yet their rise had only begun. The world would soon be shattered by fire and darkness, and in that crucible of extinction, snakes would either perish or seize their place as some of the most remarkable survivors in Earth's history. 66 million years ago, Earth trembled under one of the most violent events in its history. A massive asteroid more than 10 kilometers wide plummeted into what is now the Yucatan Peninsula. The collision unleashed energy equal to billions of atomic bombs. In an instant, forests ignited, tidal waves scoured coastlines, and a global winter descended as dust and debris veiled the sky. The age of dinosaurs, creatures that had ruled for over 150 million years, was brought to a fiery and catastrophic end. Roughly three-quarters of all life vanished. Yet amidst this apocalyptic destruction, snakes endured. Unlike massive dinosaurs that required constant feeding, snakes could slow their metabolism, surviving months without food. While other animals perished in the open, snakes took refuge underground and within hidden crevices. Their burrows became fortresses, shielding them from firestorms, acid rain, and freezing nights. They were quiet survivors, waiting while giants fell. When the dust finally began to clear, the Earth had changed forever. The Paleocene epoch dawned cloaked in humidity and heat. Vast tropical forests spread like emerald carpets across the planet. With dinosaurs gone, a new hierarchy emerged. Mammals diversified rapidly, birds flourished, and reptiles too adapted to fill the many vacant niches. For snakes, this was an age of opportunity. They slipped into ecosystems left empty, becoming stealthy hunters in a world reborn from ash. Among these serpentine pioneers rose a true giant, Titanoboa cerionensis. Stretching an astonishing 13 meters, weighing over a ton, Titanoboa was the largest snake to ever live. To imagine its presence is to conjure a nightmare of scale. Picture a shadow moving beneath the surface of a swamp water, rippling softly before a massive head bursts forth. With curved teeth, it seizes its prey, perhaps a lungfish, perhaps even a young crocodilian. Then coils thicker than a man's torso wrap around the victim. With crushing power, Titanoboa constricts until bones snap and breath ceases. This was not merely a snake. It was an apex predator in a world without dinosaurs. Fossils found in the Carajon coal mines of Colombia reveal more than size. They tell of the environment Titanoboa called home-sweltering rainforests with average temperatures above 30 degrees Celsius, where humidity hung heavy in the air. Such heat was vital for reptiles of such magnitude could only thrive in climates that fueled their cold-blooded bodies. In this greenhouse world, Titanoboa was both ruler and relic, a living testament to how snakes could expand beyond all natural limits when conditions allowed. The sheer enormity of Titanoboa may also have inspired echoes in human imagination millions of years later. Across cultures, giant serpents appear in myth. The Norse Jörmungandr encircling the world, the Indian cosmic serpent, Ananta Shesha, or the water dragons of Amazonian legend. While humanity would not meet Titanoboa, the memory of immense snakes seems to linger in our storytelling as though ancient fears were passed down in the marrow of time. But Earth never rests. By the late Paleocene into the early Eocene, the climate began to shift again. The once endless rainforests slowly contracted, replaced in many regions by open woodlands and grasslands. For snakes, this meant change. The dense canopy where ambush was simple gave way to exposed plains where prey was swift and visibility vast. To thrive, snakes would have to innovate. They could no longer rely solely on brute strength or stealth. Evolution pressed them toward refinement. New weapons, new senses, new strategies. Out of this challenge would emerge venomous fangs, infrared vision, and the uncanny forked tongue. These were the tools that would transform snakes from survivors into masters of predation across the globe. And so, from the ashes of extinction, serpents slithered forward, not diminished, but empowered. They were creatures born of catastrophe, architects of adaptation. The fall of the dinosaurs had not ended their story. It had given them the stage upon which to rise. As forests receded and grasslands expanded, the hunting grounds of snakes were transformed. Open habitats were a very different battlefield, no twisted roots to hide beneath, fewer shadows to stalk from. Prey here, rodents, birds, and early ungulates were faster, more vigilant, and harder to ambush. Strength alone was no longer enough. To remain predators, snakes had to become innovators. The answer lay in venom. Unlike the slow suffocation of constriction, venom was efficient, a chemical spear delivered through needle-like fangs. The earliest ancestors of vipers and elapids developed fast-acting toxins capable of paralyzing or killing prey within moments. This gave them a decisive advantage in wide-open terrain, where every second mattered. Striking, retreating, and then waiting for venom to do its work was safer and faster than wrestling with prey under the scorching sun. Venom was more than a weapon, it was a revolution. Just as humans would one day invent gunpowder and chemical warfare, snakes invented their own biochemical arsenal tens of millions of years earlier. Each drop of venom was a cocktail of proteins and enzymes fine-tuned by evolution to target nerves, blood, or muscle. Some venoms killed with terrifying swiftness, others incapacitated with agonizing precision. In this invisible arms race between predator and prey, snakes became nature's silent chemists. But evolution did not stop at venom. For a hunter that often struck in dim light or dense brush, new senses were needed. Pit vipers developed specialized organs near their nostrils, tiny hollows capable of detecting infrared radiation. In essence, snakes gained night vision without eyes, seeing the warmth of prey as glowing signatures in darkness. This adaptation allowed them to hunt mammals in the dead of night with uncanny accuracy. Imagine a mouse scurrying through tall grass at midnight, unseen by any predator except for the snake, whose heat-sensing organs paint a vivid picture of its target against the cool backdrop of the earth. Meanwhile, the forked tongue emerged as another innovation. Unlike most animals, snakes did not use their tongues for taste, but as tools of navigation. By flicking them into the air or across the ground, they gathered invisible chemical cues, particles of scent too faint for ordinary noses. Drawn back into the mouth, these signals were fed into the Jacobson's organ, a sensory chamber that translated chemistry into direction. In this way, a snake could quite literally smell in stereo, comparing left and right tongue tips to follow invisible trails. To ancient observers, such behavior appeared supernatural. A serpent tasting the very air, reading the world in a language no human could comprehend. As climates continued to shift, snakes pushed into nearly every environment imaginable. In deserts where loose sand made crawling inefficient, they developed a new form of movement, sidewinding. By lifting portions of their bodies while sliding others, they could glide across dunes without sinking. Each motion left a pattern of graceful J-shaped tracks across the sand, as though the earth itself recorded their dance. This adaptation made snakes masters of some of the harshest landscapes on Earth, where few other predators could thrive. In tropical forests, arboreal species grew long and slender, balancing on branches, striking at birds in mid-flight. In wetlands, semi-aquatic snakes perfected the art of ambush, their nostrils perched above the waterline like crocodiles. Evolution painted snakes into every corner of the world, each niche sculpting new weapon senses and strategies. Humanity, arriving late to this stage, noticed. Across cultures, snakes became both feared and worshipped symbols of mystery. To the Greeks, the serpent was sacred to Asclepius, god of medicine, its venom paradoxically tied to both poison and cure. In Hindu tradition, the Naga embodied both danger and divine protection. Indigenous peoples of the Americas told of giant water serpents guarding rivers, much like their ancestors may have remembered encounters with immense boas and anacondas. Where humans saw terror, they also sensed wisdom and ancient power coiled in silence. By the Miocene and Pliocene epochs some 20 to 5 million years ago, snakes had perfected their arsenal. They were no longer awkward lizard-like hybrids, but true serpents, venomous, perceptive, resilient. The earth itself was cooling, drier grasslands spread wider, and deserts expanded. Yet snakes adapted as they always had. Their story was one of invention, each challenge met with an evolutionary twist. But another challenge loomed far greater than grasslands or deserts. The ice ages were coming, and for cold-blooded hunters who thrived in warmth, this would be the sternest test of all. The earth grew colder. Around 2.6 million years ago, the Pleistocene epoch began a time marked by advancing and retreating glaciers. Vast sheets of ice swallowed the northern continents, locking away oceans and transforming lush regions into frozen deserts. For snakes, creatures bound to warmth, this was a perilous age. Their dominion shrank, confined to belts of tropical and temperate refuge nearer the equator. In the chill of temperate zones, survival required adaptation. Many snakes entered a state known as brumation, a reptilian cousin of hibernation. In this suspended rhythm, their bodies slowed. Hearts beat faintly, and hunger faded into dormancy. Tucked in rock crevices or beneath soil, they weathered months of cold in silence. It was a strategy of patience, life reduced to a whisper until warmth returned. While mammoths thundered across icy steppes and saber-toothed cats prowled for prey snakes, became nearly invisible participants in this drama. They were no longer rulers of swamps like Titanoboa, but survivors clinging to the margins. When the ice ages ended, much of Earth's megafauna disappeared forever. Woolly rhinos, giant ground sloths, dire wolves. Yet snakes endured as they always had, slipping through the cracks of catastrophe with quiet resilience. As humanity rose during these same ages, our relationship with snakes deepened. To early hunter-gatherers, snakes were both threat and teacher. A bite meant death, but the same venom also became the foundation of cures and rituals. In myth, serpents embodied duality, destroyer and healer, deceiver and protector. In the Bible's Garden of Eden, the serpent tempts. In Mesoamerican tradition, the feathered serpent Quetzalcoatl brings knowledge and civilization. In Asia, the Naga guards rivers and temples. The limbless body became a canvas for human imagination, embodying both fear and reverence. Modern snakes carried forward the legacy of innovation. Cobras perfected defensive displays, hoods flaring like banners of warning. Vipers refined strike speed to fractions of a second. Pythons and boas, though non-venomous, became living symbols of raw strength, their coils crushing life from creatures larger than themselves. Some even developed extraordinary locomotion, like the sidewinders of North America's deserts moving in mesmerizing rhythms across sand dunes. Snakes were no longer merely survivors of deep time, they were models of specialization, masters of the environments they inhabited. But a new predator had risen us. Unlike asteroid strikes or ice sheets, humanity reshaped the planet with intent. Forests fell to agriculture, wetlands drained, and urban sprawl carved apart once continuous habitats. Invasive animals, mongooses in Asia, cane toads in Australia, disrupted ecosystems preying upon or outcompeting snakes. Yet paradoxically, snakes adapted again. Many now live quietly in our fields, gardens, and cities, feeding on rodents and pests that thrive in human shadow. They are our uninvited neighbors, guardians of balance in ecosystems we scarcely notice. Culturally, snakes remain mirrors of our own contradictions. Some societies fear them to the point of extermination. Others preserve them as sacred beings. Even today, the staff of Asclepius, twined by a serpent, symbolizes medicine worldwide. The creature that once haunted our myths now sits on hospitals representing healing. Few animals carry such layered meaning across time and civilization. Looking forward, the future of snakes is uncertain. Climate change, habitat loss, and persecution threaten countless species. Yet if their history teaches anything, it is this: snakes are survivors. They have slipped through asteroid winters, tropical upheavals, and frozen millennia. They endured when giants perished. Their story is not one of dominance, but of persistence, reinvention, and silent triumphs. To see a snake today, whether a cobra in the desert, a python in the jungle, or a garter snake in a suburban garden, is to witness a lineage older than most mountains. A creature shaped by catastrophes and carried by resilience. They are living fossils and restless innovators, feared and revered in equal measure. Perhaps this is why snakes continue to fascinate us, because in their eyes and their forked tongues, tasting the unseen air, we glimpse the endurance of life itself. A symbol of death, yet also of healing. A creature that once walked on legs but chose a different path. A survivor that whispers to us across deep time that to adapt is to endure.